And like I said, all of these calculations can be found in the solution key to the practice test for test 3. I'm going to go ahead and erase this now because I only have a small window here. So now I'm going to go to step 2. Step 2 is where you make your confidence interval. Now we're going to use the mean, because the confidence interval estimate for the unknown population mean, or the unknown mean annual income for all U.S. households, you subtract the error from the sample mean and add the error to the sample mean. So the confidence interval here is x bar minus e to x bar plus e. That's in the cheat sheet under step 2. And here that would be what? We'd take the sample mean, 34,620.43, and subtract the error, which was 922.39, and go from there to 34,620.43 plus 922.39. So we subtract the error from the sample mean and add the error to the sample mean. And when you do that, you end up getting $33,698.04 to $35,542.82. That all come in there? Like I said, all of this is in the solution key to test 3 that's online, all these calculations. So you can check them on your calculator. So the interpretation is going to be, there is a 95% likelihood that whatever the unknown mean annual income for all U.S. households are, that mean annual income should lie somewhere between $33,698.04 and $35,542.82. We don't know what that actual population mean is, what that mean annual income is for all U.S. households. We can only say with 95% likelihood it should be between these two numbers. And if you think about it, that means there's still a 5% chance that the mean annual income of all U.S. households does not lie between these two numbers. We can only say with a probability of 0.95 that the unknown annual income of all U.S. households based on this study should be between $33,698.04 and $35,542.82. So that's the confidence interval estimate there for the unknown mean annual income of all U.S. households at a confidence level of 95%. So let's move on to problem 8. In problem 8, we're given a similar set of statistics where instead of trying to estimate the mean annual income of all U.S. or American households, we're trying now in problem 8 to determine or estimate the mean annual income of all European households. And so we're going to get a sample of European households taken at random, and we'll get a set of sample statistics like this for the sample of all European households. And from that, we'll get the confidence interval estimate for the mean annual income of European households. And then from that and this confidence interval that we got for the mean annual income of U.S. households, we'll try to figure out if there's evidence to suggest that there is an actual difference in the mean annual income of American households and the mean annual income of European households. The way this method works is there's two different methods in the cheat sheet given for how to do this. But we're going to use the first method because we've already computed one confidence interval for the U.S. households. So since we've already done one confidence interval for the U.S. households, it would be easier on the cheat sheet to use method 1 for trying to determine if there's a significant difference between two population means. So we're going to take the sample statistics that we get from problem 8, that were taken from a sample of European households. We'll get a confidence interval estimate like this, but only for the estimate for the mean annual income of European households. And if those two intervals, this interval and the interval from problem 8, have no overlap, then that would suggest that if one mean is in this interval and the other mean is in the other interval and the two intervals don't overlap one another, that would be enough evidence at least a 0.95 times 0.95 likelihood, or 95% squared likelihood, that the two means would be different. Now, if the two intervals happen to overlap each other, the interval from problem 7 and the interval from problem 8 do overlap, then that means there would be a possibility, at least at this confidence level, that the mean annual income for the American households and the mean annual income for the European households could be the same mean. Because we don't know the mean annual income for either the Americans or the Europeans. We only know a confidence interval estimate at a particular confidence level for both. So if the two intervals happen to overlap each other even slightly, you won't be able to draw any conclusions about draw the conclusion that the two unknown population means are actually different from one another. But if the two intervals don't overlap, then that would suggest that if one mean is trapped in one interval and the other mean is trapped in the other interval at the same confidence level, then there would be at least a 0.95 times 0.95 probability that the two means would have to be different from one another. And that would at least provide evidence that whatever the mean annual income is for American households and European households, at least if the intervals don't overlap, you would have evidence that the two means are not the same, that they would be different means for annual income for American households and Europeans. So let's go ahead and compute the interval from problem 8, then see if it overlaps this interval, and then we'll draw our conclusion. And that's how chapter 21 ends. Using confidence intervals for two different subpopulations to try to see if you have evidence that two different population means are different or not. So that's what we're going to do in problem 8. So for problem 8, we're doing the same kind of study, only we're taking European households, not American households, to estimate the annual income of all European households. So we go to the practice test for problem 8, and it says, in addition to the statistical information given in problem 7 above, suppose that a random sample of 417 European households. So the sample size for European households is 417. That's the number of European households that were selected at random to form our sample. From that, it was determined that the mean annual income of those 417 randomly selected households came out to be $32,972.13. And the sample standard deviation for this sample came out to be $7,277.52. Also, we stay with the same confidence level here, which is 95% confidence. So there's the four pieces of information we got from the sample of European households that were asked what their annual income was. Now, from that, I'm going to erase this. It's all printed in the solution key. We're going to go back through those three steps, and we're going to get a confidence interval estimate for the population mean of all European households and the mean annual income for all European households from these sample statistics. So the first thing I'm going to do is take these numbers and plug into the margin of error formula. So using those numbers, step 1 says that the margin of error is the critical value that goes with 95% confidence times the sample standard deviation divided by the sample size. And here we had 95% confidence, so once again we're using a critical value of 2. The sample standard deviation here was $7,277.52. And then we divide by the square root of the sample size, which is the square root of 417. So 2 times 7,277.52, all divided by the square root of 417. If you enter all that into your calculator, it should come out to be the margin of error comes out to be $712 $2,252.76. Now, step 2 is, I'm going to go ahead and erase this. Just either write that down or look on. That's the error for this sample of European households. It's $712.76. So now we're going to subtract that error from the given sample mean and add that error to the given sample mean for this sample. And that'll give us the confidence interval estimate for the population mean of all annual income, mean annual income for all European households. So there's our confidence interval estimate, and the mean here was, for problem 8, I'm having problems here. So X bar minus, so the mean came out to be 32,972.13, and then we subtract the error, which came out to be $712.76. Well, let's look at it like this, because these are pretty big numbers. I'll write it like this. X bar minus E is equal to, X bar was 32,972, and then minus the error, minus 712.76 equals, and that difference on your calculator should come out to $32,259.37. So $32,259.37 is X bar minus E, and then X bar plus E would be $32,972 plus $712.76, and that is equal to $33,639.89. So our interval goes from, make sure this is all coming in the window here. So our interval actually goes from $32,259.37 to there's not much board space here, I apologize. $32,259.37 to $33,639.89. So that's the confidence interval. So what that means is, that means that with 95% confidence, the actual mean annual income of all European households should be somewhere between $32,259.37 and $33,639.89. Now, we want to know whether we have from problem 7 and 8 evidence, significant evidence, that the mean annual income for U.S. households is not the same or different than the mean annual income from European households. Remember, from problem 7, our confidence interval in problem 7 was 33,698.04 to 35,542.82. And then in problem 8, our confidence interval was 32,259.37 to 33,639.89. The question is, if there's a 95% likelihood that the average income of all American households is between here and here, and there's also a 95% likelihood, is this coming up? Can't tell. Oh, here. There's the two intervals. Yeah. Okay. And what you see is if you look at the interval from problem 7 and you look at the interval from problem 8, what you notice is the largest number in the interval for problem 8 is smaller than the smallest number in the interval for problem 7. So there is no overlap between the interval for problem 8 and the interval for problem 7. The interval from problem 8 goes up to 33,639. And the interval for problem 7 doesn't start till you get to 33,698. So the largest number in the interval for problem 8 is still smaller than the smallest number for the interval in problem 7. So what that means is the two intervals do not overlap one another.